Hello, today is Monday, January 14th. For our warm-up, we are given a linear system and we are asked to solve the system. So we have two equations, x equals -3 and y equals 2x plus 4. We know that to solve the system is to find the point of intersection of the two lines. So for us to figure that out, first we have to graph these two lines. So let's do that. I'm going to get started with my second equation. One way to graph a line is by using the y-intercept and the slope. When your equation is written in the form y equals mx plus b, or the slope-intercept form, all you have to do is to pull out the b value, which is the number by itself. So in this case, it's 4. So your b value, that's going to be your first point on the y-axis. Remember that it's on the y. Okay, that's why that b is called the y-intercept. It's a point on the y-axis. So let's see, where is that? 1, 2, 3, 4. So right here, that's your y-intercept. B equals 4. Now we're going to move to a second point. To move to the next point, we're going to use the m value, or the slope. That is the number that is being multiplied to x, the number directly next to x. So the number here is 2, so that means our slope is 2 over 1. Remember, our slope must be in fraction form because slope is rise over run. So the numerator tells you how many units you're going to go up or down. It's a vertical movement. Since this is positive 2, that means you're going to go up 2. And then the denominator is telling you a horizontal movement. Since it's positive 1, you're going to go 1 to the right. So from your b value, you're going to move up 2, 1 to the right. So up 2, 1 to the right. And you can do that one more time so your line will be more precise. So up 2, 1 to the right. Okay, once you have your points, go ahead and connect those points so you can draw your line. So remember, you don't stop right here. You have to extend it. You have to extend so your line will be accurate. Okay, you have to use a ruler. Okay, so we're done with the second equation. Now the first equation, this one is not written in y equals mx plus b form. This is just x equals -3. When you have an equation like this, that means you have a vertical line at x equals 3. So on the x-axis, you're going to plot a point at -3. So x-axis -3 right here, going to plot a point, and then you're going to draw a vertical line like this. There you go. So the blue one is for x equals 3. So now you're going to find the point of intersection. That will be the solution to your system. So let's see. Oh, they're crossing right here. So the solution to this system would be the coordinates of this point, which is -3, -2. So the solution to this system is -3, -2. It has one solution because it has one point of intersection. Now, can we solve a system some other way? The answer is yes, and that's what we will be learning today. We are going to solve linear system by substitution, and our learning target is that you will be able to solve system of equations using algebra. So we won't be graphing anymore. We will be using math to solve linear system. So let's get started. Let's try to solve the first problem that we got here. Remember, we got -3, -2. So let me put it right here. -3, -2. Let's see how are we going to solve this system by substitution. Okay, so you are given the system. So it's the same equations we had earlier. You know that x is equal to -3, and you can use that information to solve for y, because you already know x is equal to -3. They're telling you x is equal to -3. So when you write down your solution over here, you already know this is x, this is y. I already know x equals -3 because they gave it to me, x equals -3. Now all I have to do is to solve for y. If I know that x is equal to -3, I can use that value of x in the second equation to solve for y. So you're going to say solve for y using x equals 3. Because I know x is equal to 3, -3, because it was given to me. So remember, this is just plugging in. We're just going to plug in -3 in place of x. So you write down your equation, y equals 2. Remember that 2x, that means multiplication. So put parentheses in place of x and then plus 4. That 4. Now, just plug in the value here. Instead of writing x, we're going to write -3. And then now you just have a simple equation. Solve for y. Y equals 2 times -3 is -6 plus 4. -6 plus 4 is -2. So now we have values of x and y. So y is -2. And we know that this is correct because we already solved this by graphing earlier and we got the same x and y coordinates. Okay? All right, let's have another example. Okay, again, this one, you are given a linear system. So you know if there's one solution, you're going to have x and y coordinates here, right? Let's check the equations. Oh, this one they already gave you that y is equal to -6. So you don't have to solve for y. You can write it over here. Y equals -6. All you have to figure out now is the value of x. So you have to solve for x. So you're going to say solve for x using y equals -6. So you're going to write the second equation, -9x minus 5. Remember now, instead of writing y, we're going to write parentheses. Equals -15. And then, inside the parentheses, we're going to plug in the value of y, which is -6. Now, this is just simple equation. You have one variable that you're going to solve. So let's solve for this. So we're just going to bring -9x, bring it down. And then this is -5 times -6 is +30 equals -15. This is just a two-step equation. So let's subtract 30 from both sides. So no more 30 on the left side. You're left with -9x. -15 minus 30 is -45. We have to solve for x. We have to get rid of -9. So we will undo multiplication by dividing both sides by -9. So negative 9 divided by negative 9 is 1. Bring down the x, bring down the equal sign. Negative 45 divided by negative 9. First, let's deal with the sign. Negative divided by a negative, that's a positive. Okay. And then 45 divided by 9, that's 5. So x equals 5. So now we know, oh, the x coordinate of the point of intersection is 5. What does this mean? That means when you graph the two lines, they will cross at the point 5, negative 6. Okay? All right, let's have another one. Oh, again, you have a linear system, so you know that the solution to this, if there is one solution, it will be an ordered pair, x and y. Now, the other examples, they gave you values of either x or y. In this problem, they didn't. It's a little bit different, right? So let's see, how are we going to do this? Well, if we say that y is equal to x plus 4 and y also is equal to x minus 2. According to equation 1, y is equal to 2x plus 4. According to equation 2, y is equal to x minus 2. Now, instead of writing y over here, can I write 2x plus 4? Like I will substitute, I will plug in this value of y, 2x plus 4, instead of writing y. Is that possible? Of course. Since I know that y is equal to 2x plus 4, I can plug in this value down here. Instead of writing y, I can write that whole thing because y is also equal to that. So I'm going to write 2x plus 4 is equal to, and then this one I'm just going to bring it down, x minus 2. So now, as you can see, you have a new equation here, and there's only x. You can solve this. This is an equation where you have variables on both sides. So let's solve that. You have 2x plus 4 equals x minus 2. Let's collect all the variables over to one side. So I'm going to take away that smaller of the two, minus x. So on the left side, 2x minus x is x. And then plus, bring down the 4. X minus x, that's gone. Bring down negative 2. Now this is just one-step equation. X plus 4 equals negative 2. We have to get rid of plus 4. So we will subtract 4 from both sides. So on the left side, no more 4. Bring down the x. Negative 2 minus 4 is negative 6. So we figured that x is equal to negative 6. Now I'm going to put that value over here for x. X is negative 6. Now I just have to figure out y. How do we solve for y? Solve for y. Well, if we know that x is equal to negative 6, we can use that value to solve for y. You can use the first equation or the second equation. It doesn't really matter. Let's use the first equation. So y equals 2x plus 4. So I'm solving for y. I'll bring it down. 2. Remember, this means multiplication, so I'm going to put parentheses. And then plus 4. X, I found out, is negative 6. So I'm going to put negative 6 over here. So y equals 2 times negative 6 is negative 12. Bring down plus 4. y equals negative 12 plus 4 is negative 8. So from equation 1, I found out that y is equal to negative 8. A way to check this, if this is correct, is to plug in your x on your second equation. If you'll get the same value for y, that means your answer is correct. So let's do that. Let's use the second equation now. Y equals x minus 2. Let's use that to solve for y. So y equals x is negative 6. So negative 6 and then minus 2. And then y equals, what's negative 6 minus 2? That's negative 8. So we got the same answer. That means our answer is correct. Y is negative 8. So that's the solution to this system. That means these two lines will cross at the point negative 6, comma negative 8. Okay, I'm going to do the last example over here. So again, you're given a linear system. You know that if there's one point of intersection, you're going to have x and y coordinates here. So this one again, they didn't give you any value of x or y. They gave you an expression equivalent to y. So when you have something like this, since y is equal to x plus 4, and y is also equal to negative 3x plus 12, so we can say that this two, instead of writing y over here, I'm going to plug in this value. So I'm going to say x plus 4 is equal to negative 3x plus 12. Now I'm going to solve for x. This is just equation with variable on both sides. So let's take away the smaller of the two. So let's cancel out the negative 3x. We can do that by adding 3x to both sides. So x plus 3x is 4x plus 4. No more x's on the right side. And then 12. And then 4x plus 4 equals 12. This is just a two-step equation. So let's get rid of 4 by subtracting 4 from both sides. On the left side, you only have 4x. 12 minus 4 is 8. 4 times x equals 8. Divide both sides by 4. So x equals 2. So we found the value of x. We said that is equal to 2. So let's put it over here. X equals 2. Now you're going to solve for y. Again, your x is equal to 2. You can use either one of these two. I'm going to use the first one because it's a lot easier. So I'm going to say y equals, so it's x plus 4. So y is equal to, we found out x is equal to 2 plus 4. So y equals 6. So we got y equals 6. We will check our answer by plugging in x equals 2 to the second equation. If we get the same value for y, that means our answer is correct. So let's do it. Y equals negative 3x plus 12. Y equals negative 3 times x, and x is 2, and then plus 12. After you plug it in, you just simplify. Negative 3 times 2 is negative 6 plus 12. So y equals negative 6 plus 12 is 6. So since we got the same value for y, that means the y is really 6. So your answer is correct. Okay, so from here we figured out that, hey, I can actually solve a system algebraically by using substitution. And I think this is a lot less work than graphing because you don't need a ruler to do this, right? Okay, I'll see you in class. I hope you find this video helpful. Bye bye.